Hello everyone, my name is Stephanie Huff and the topic of this video is converting alcohols to alkyl halides. So what is an alcohol functional group? The different reagents that can be used to make an alcohol and alkyl halide, and we'll go through the reaction mechanisms of it as well. That's what we're doing today. So what is an alcohol? The functional group alcohol is OH attached to any organic molecule. So I have a couple shown here. The different reagents we can use when we're starting with an alcohol on the left and ending with an alkyl halide on the right. We can use HX, where X is bromine, chlorine, or iodine. We can also use SOCl2. We can use PBr3 and PCl3. So with HX you have the option, you can produce an alkyl bromine, an alkyl chloride, or an alkyl iodide, but the other three are limited. With SOCl2 you're only going to be able to make an alkyl chloride. With PBr3 you're only going to be able to make an alkyl bromide, and with PCl3 you're only going to be able to make an alkyl chloride. So let's dive right in. When we're using HX, we can use iodine, chlorine, or bromine like I talked about. So here's an example of the reaction mechanism. So where do we start with this reaction? It's actually going to be the lone pairs on the oxygen that are going to reach out and grab the hydrogen from the HBr. Now we have Br minus in solution, and our molecule is now attached to OH2. So here we have our OH2 is positive on the oxygen, and that's going to make for a great leaving group. So the Br minus is going to come in SN2 style and kick off the OH2, and it's going to leave you with an alkyl bromide and water. Let's do one more, because SN2 is not the only way that these reactions can happen. So here we have our molecule with the alcohol group, and we're using HBr again, but it can be HBr, HCl, or HI. So the oxygen is going to start this reaction off reaching for the hydrogen in the HBr, and that's going to produce the same molecule but now has an OH2 attached to it, and that is positive. So the Br minus on this reaction is actually going to react after the leaving group leaves. So this is an SN1 reaction, and there's our final product. Now I have some examples using SOCl2 as a reagent. So here's just a generic example. And again, with SOCl2, the only halides available are going to be chlorides. So your product's always going to be an alkyl chloride. So for example, we have an alcohol here, an SOCl2. And again, the oxygen is going to kick this reaction off. It's kind of hard to see the reagent written in this form, so I rewrote it. So we have the alcohol reaching out, and it's going to kick off one of its chlorines. So again, just like in the HX reaction, this is going to make for a better leaving group, and we have our Cl minus in solution that's going to come in and make this an alkyl chloride. So after it looks like this, there is this troublesome hydrogen here, and there's just going to be a pyridine in solution that's going to take care of that for us. And then once that's removed is when the chloride can go ahead and bump the other molecule off. And there we have our final product, our alkyl chloride. So the other two reagents I mentioned were PBr3 and PCl3. So these reagents are both going to be seen with ether and 35 degrees Celsius in the reaction arrow area. So just keep your eye out for that. They are interchangeable. It's the same reaction mechanism. Just for one, you would use, PCl3 if you wanted an alkyl chloride, and you would use PBr3 if you wanted an alkyl bromide. So for our example, I use PCl3, and you're always going to see it reacting with an ether in 35 degrees Celsius. And again, I rewrote the reagent here, but just as in the other reaction mechanisms we went over, the oxygen is going to reach out for the P there and kick off a chlorine into solution. So again, we have a better leaving group, and the Cl- is going to come in and replace what the alcohol group has become. So we have our pyridine taking care of the hydrogen in these two reactions as well, whether it's PCl3 or PBr3. We're going to have the pyridine in there to take care of that hydrogen and have the bond collapse back onto the oxygen. So then the chlorine is able to come in and substitute the alcohol group. And there is our product. So I hope you guys learned a lot. I sure did making this video, and thanks again for watching.